target 3 today, which is force and interaction. The big idea of this unit is that force is half an interaction. So two things are always touching each other, and that is where the transfer of energy takes place also. Day 2 is Newton's second law experiment. In day 1, they've already learned about equilibrium situations and disequilibrium where there is a net force, and all they know is that it accelerates, it speeds up or slows down. They don't really know much of quantitatively what's happening. So that is why we start to investigate what does happen in those situations. In my opinion, this is one of the most impactful experiments in all of classical mechanics, but because it's so hard to get good data, we oftentimes don't have it placed that way, or at least I haven't in my class before data mining. Data mining means that we're going to use Excel data given to them for them to do the lab. And there's two different research questions that are going on. How does the total force affect acceleration, and how does mass affect acceleration with the corresponding things controlled? So let's take a look. Here I have the Excel. And I don't tell them there's two actual sheets here, and they have to look at both of them and figure out what one has the relevant data. So this is same push on different balls. So we see that it is the constant force. So this one is going to help us for answering how does mass affect. So our x variable is going to be the mass of the ball, and then they can ignore everything except for this last column, which is acceleration, and that will be their y in Logger Pro. Now the people that have how does net force affect acceleration will have this data sheet to use, and all they have to do is copy and paste this one column of total force and acceleration as their y variable here, and they will get these two graphs. So how force affects acceleration for mass being controlled, and how mass affects acceleration for force being controlled. Now during the whiteboard meeting, I suggest first starting with A is proportional to 1 over m, the inverse, because the constant in that inverse equation is F total, or F net. Students can get that on their own. Now, even knowing that, going to F is proportional m, where 1 over m is the slope, they will still struggle, but with this floating out there, someone will figure it out. And if not, go ahead and give them that guidance that, look, this equation it's going to be A and F with 1 over m, and then again, we're just going to have A is 1 over m, A is proportional to F, and that number, the slope, is the inverse of the mass. So go in that order. And then lastly, this ends with a real world basketball or ball bearing being rolled on carpet or a hard floor, just as long as there's enough friction. Another separate video will be made to walk you through how to set up Excel with the right force of friction for your scenario. Thanks.